Hello everyone, welcome back to Discrete Mathematics with me Adila Krishnadi. We are still discussing graph representation. Now we look at the third representation, incidence matrix. We start with the undirected graph and then we will discuss the directed graph after that. Incidence matrix is slightly different than adjacency matrix. In adjacency matrix we look at so the column and the rows are the nodes essentially, right? So in incidence matrix the rows are the nodes. Yeah, so if you have m nodes, so that means you have m here, and then the columns will correspond to the edges. So this is the rows and this gives us the columns. So that means if you have m nodes and n edges, then you have m by n matrix. Now of course, if you have a much larger number of edges compared to the number of nodes, then adjacency matrix would take much less space than incidence matrix, right? And if you then compare these two adjacency lists, it would be even adjacency matrix if the graph is actually dense, then it will be better to use adjacency matrix, meaning that if you have many edges. But if you have very little or very small number of edges, then adjacency list might also be useful there. So incidence matrix will be the size of incidence matrix depends on the size of the number of nodes and the number of edges, whereas in adjacency matrix we only depend on the number of nodes. Now incidence matrix D would have the I, jth entry, the Dij, defined as follows. So Dij is defined to be 2 if Phi is the endpoint of Ej. Phi is the endpoint of Ej, and Phi is the only one, meaning that Ej is a loop at Phi. So we define it as 2 here. Now, and if Ej is not a loop, so that is for example St Ej is equal to Phi and Phi k, then Dij is the same as Dkj, which is 1. Yeah, okay, where here is I is not equal to k. Yeah, so you set 1 here, but if there is no edge, if Ej is not incident at Phi, then we put 0 there. So let me repeat, Dij is 2 if Ej is a loop at Phi, and 1 if Ej is not a loop but incident at Phi. And of course, sum over the row will give us the degree of Phi, and sum over the jth column will always be 2. Now let's see an example of undirected graphs. So let's use the same graph, but this time let us label the edges with E1 up to E9. So therefore we have 4 by 9 incident matrix. So you have A, B, C, and D, and then you have E1, E2, E3, E4, E5, E6, E7, E8, and E9. Sorry, let me just redo this. Yeah, so from A, well, E1 is a loop, so we put 2 here. E2 is an edge incident at A, so we put 1 here, and we put also 1 here. It was also 1 here, and the rest 0. And then for B, This is 0 and this is 1, this is 1, and then this is 0 and this is 1, this is 1, because E2, E3, E5, and E6 are the edges incident at B, and these are 0. And finally, and C, for C you have 0, and the only edges incident at C is E4 or RE4, E7, and E8. And for D, 0 here, and then E5, E6, E7, E8, and E9. So the sum here is always 2, the column sum, and the row sum here is always the degree of the node. Yeah, 5, 4, 3, and 6. Yeah, so that's incidence matrix for the undirected graph. Now, how about incidence matrix of directed graphs? Now, this one is slightly tricky because we have directions. So how do we represent directions here? Well, the idea is that for the outgoing direction, we will use 1, and for the incoming edge, so for outgoing edge we use 1, for incoming edge we use -1. Yeah, but loop would be special because loop is actually simultaneously an outgoing and incoming edge to a node. So let's start with the non-loop edges. So if EJ is an edge, so EJ is outgoing from VI. Yeah, EJ is not a loop, of course. Yeah, non-loop. Yeah. Then you have that Vij. Remember, the I is the node, so Vij is 1. Now, if EJ, the non-loop, is incoming to Vi, then Vij is -1. Now, if EJ is actually a loop at Vi, then we set it 2. Now, this makes some property of the matrix slightly complicated, but that's fine. In particular, if the graph does not contain loops, yeah, graph contains no loop, then it only contains 0, 1, or -1 entries. Yeah. So let me repeat: if EJ is a loop, then Dij is 2. Otherwise, Dij is 1 if Vi is the source of EJ, and -1 if Vi is the target of EJ. And the out degree of Vi is equal to the sum of Dij, the row sum, except the entries for which the Dij is 2. Yeah. And the in degree is also the row sum, but only taking the value -1 and half of the loop. Yeah. And also, again, the sum of the column will be 2 if EJ is a loop and 0 otherwise. So now let's see. Yeah, here's an example. So you have A, B, C, D, E, F. Yeah. Let me just put it here. So E1, E2, E3, E4, E5, E6, E7, E8, E9, and E10. Yeah. So this is we need to tighten this a little bit. E2, E3, E4, and then E5, E6, E7, E8, E9, and E10. Yeah. Yeah. So now, so to make it clear, yeah. All right. So um, so there is an edge from A to B. So therefore, E1 is the edge from A to B. So therefore, 1 here and -1 here. Yeah. E2 is an edge from C to B. So that means has to be -1 here and then 1 here. Well, yeah. And 0. Hold on a second. So here 0, 0, 0, and 0, and then 0, 0, 0, and 0, and this is -1 because E10 is an incoming to A. For B, E1 and E2 are incoming to B, not E3, yeah, but E8 and E9 are outgoing edges from B, so you put 1 here, and this is 0. How about at C? You see there is a loop, so E2, so this is 0, and then E2 is 1 because it is outgoing, and the loop E3, so we put 2 here, and E4 is outgoing at C, E5 is incoming, and then 0 for the rest. Yeah. Now how about D? At D, you look at the incoming, the E1, E2, and E3 are 0 because they are not incident at D. And then E4 is incoming, so you put -1. E5 is outgoing. E6 is incoming, and the rest are 0. Yeah. For E, this is 0, 0, and 0, and 0, and 0, and then E6 is outgoing, E7 is a loop at D, and then E8 is incoming, and E9 is also incoming, and E10 is outgoing. Yeah. And for F, well, or R0 because F is isolated. Yeah. So that will be the incidence matrix. You see that the sum here, this is 0, except this is E3 is loop, so you put, so the sum here is 2, so is E7. Yeah. How about the row sum? Yeah, look at the for example A, there is 1 outgoing and 1 incoming, so degree of the outgoing degree of A is 1, and outgoing incoming degree of A is also 1, because there is one the entry 1 appears 1 time and the entry -1 appears 1 time. How about for example C, outgoing degree of C is 2 plus, yeah, 2, meaning this one, yeah, and this, that is the red one, so this and this, plus half times 2, so 3, right, because we have a loop here. And then for the incoming degree of C is 1 plus half times 2, which is 2. So you look at this, so you take this and half of this. Yeah, so that's the property of incidence matrix. So hopefully this clarifies the concept, and we stop, and this ends our discussion on graph representation.